All right, people, here is the worksheet that I gave you. All right, let's apply the rules we learned in the previous video about Lechatliers' principle. Remember, whatever you do to the left side, it reacts by going to the right. Whatever you do to the right side, it reacts by going to the left. So it just moves opposite. All right, the question says, for the reaction below, which change would cause the equilibrium to shift to the right? So we want it to shift to the right. Okay, if we decrease the concentration of dihydrogen sulfide is right here. So if we decrease this, we remove it. Now it's just like pulling the plug in the bathtub. If we remove it, everything would flow to the left. Everything would shift to the left. So it's not that one. Okay? It's not that answer choice. We want it to shift to the right. If we decrease the pressure on the system, all right, from your reading in the book, you learned that if you decrease the pressure, if you increase the pressure on the system, it's going to move to the side with fewer moles. Okay, so when you have pressure, you're dealing to the side of fewer moles. Now, how many moles do we have over here? We have 1 and 2, so we have 3 total moles. Over here we have 1 and 4. Well, that's 5 total moles. Okay? So if the rule is it goes to the side with fewer moles, then everything would shift to the left, because that's where the fewer moles are. It would shift to the left. So that's not the answer choice. Okay? Increase the temperature of the system. Let's see what that will do. Yes, if you increase the temperature of the system, okay, unless it specifically says there's heat over here, which it doesn't say that. So, then yes, that would make it go to the right, because it would speed it up. It would make you make the products faster, generally speaking. So increasing the temperature would do it. Let's look at the other one. If I increase the concentration of carbon disulphide, okay, if I increase the concentration of disulphide, if I increase here, then what would happen? What would happen is, well, I'm increasing on this side, it would flow that way, to the left. So that's not right either. If I decrease the concentration of methane, okay, if I decrease the methane, then it's just like pulling a plug in the bathtub. It would flow back out of the plug. Okay, left. So that isn't either. All right? So that's the first one. Okay, let's move down to the second problem. 2, what would happen to the position of the equilibrium when the following changes are made to the equilibrium system? Following changes. This is not a multiple choice problem. Okay, sulfur dioxide is added to the system. Sulfur dioxide, that one. Okay, so if we add, then it would shift to the left. Okay? It would shift to the left. Sulfur trioxide is removed. Sulfur trioxide is removed. That's just like pulling the plug on the bathtub. It would shift left. If we add oxygen to the system, then if we add it over here, everything shifts left. So it shifts the equilibrium left. All those would shift it left. All right? And then let's get to one that has pressure in it too. Let's get to one that has pressure. Aha! Here we go. Number 3. What would happen to the position of the equilibrium when the following changes are made to the reaction? Okay, if the HCO is added to the system, so that means we add this stuff here. if we add, everything shifts to the right. It would shift it to the right. The pressure on the system is increased. So if you increase the pressure, it goes to the side with the fewer moles, because there's more space over there. Okay? It's like trying to jam people into a classroom. They're going to naturally go where they can get space. It's like trying to jam people, crowd people into a box or a subway car. They're going to naturally find space. So where is there more space? This is a toughie. You have a total of 2 moles over here. Okay? Because it says 2. And then you have 1 mole here and 1 mole here. Well, on this side, you have 2 moles. So which way does it go? Does it go to the side with 2 moles, or does it go to the side with 2 moles? And the answer for this particular problem is no change, because it can't go to the side with 2 moles if there are 2 moles on the other side. If there are 2 moles on this side, and there are 1 plus 1, 2 moles on this side, then it can't go to the side with 2 moles. No change. Okay? You guys need to read up on pages 606, I believe, through 611. 606 through 611. All the information is there. Don't just listen to what I say. Go read. You will understand it better.